Okay, so let's go over the summation homework you had. Okay, so basically you learned that all you have to do is just keep putting in the variable for I. We're going to start with the number 3. So it's going to be 2 times 3. Then we're going to go 2 times 4. And then we're going to go 2 times 5. See, that's the run. We go 3, 4, stop at 5. 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and the last thing, the big E, tells us to add it all together, so that's why that answer is 24. For this one, it tells us to start by putting a -1 in for K, and to keep going all the way to the number 3. All right, that's where I stop. That's 1, that's 0, that's 1, that's 4, that's 9. Add them all together. 2, 6, 6 plus 9 is 15. Okay, so for this one, we're starting this run by putting a -2 in for J. So that's 2 to the -2. Then I'm going to go 2 to the -1, 2 to the 0, 2 to the first, 2 to the second. So remember, 2 squared is 4, but the negative tells you to make it into the fraction 1/4. 2 to the first is 2, but the negative tells you to make it into 1/2. Anything to the 0 power is 1, 2 to the first is 2, 2 to the second is 4. All right, so this is 7, and that is 3/4. So the answer is 7.75. And for the last one, I'm going to start my run with -1. So -1 times -1 plus 1. 0 times 0 plus 1. 1 times 1 plus 1. 2 times 2 plus 1. And 3 times 3 plus 1. Well, this is easy. That's 0 times anything is 0. That's 0 times anything is 0. That's 2 times 1 is 2. That's 3 times 2 is 6. And that's 4 times 3 is 12. Sorry, so that's 820. My dog just pulled the blanket off the couch, and now she's chewing on it. Oh, the puppy world. All right, moving on. Which represents the value of this? Well, I'm going to start with putting 1 in for I. So 1 over 1 squared. Now I have to add to that 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared. That's where I stop. That's 1. That's 1/4. That's 1/9. And that is 1/16. All right, well, I'm going to add those together first because that's easy. I'm going to do this old school. I'm going to be impressive. No calculator needed. Common denominator 16. So that is 5 over 16. And now I'm going to have to add on a 1/9 to that. Okay, so it's common denominator. That's going to be, what's that, 144. And that's 45. And that's 16. And that is 11, 61, 144, add the 1. So what is 1 and 61 over 144? Well, I'm thinking it's going to be this. And let's do this. That's 144 plus 61, 510, 205 over 140. Yep, I'm right. All right, next one. This is the one I screwed up. I made a typo on it, so this is what it should look like. And just to show you, this is the type of question they're going to put on the Regents, because you can't put this into your calculator to do it. So first we're going to start by putting 0 in for x. So that's 3 minus 2a to the 0 power. Then we're going to rewrite and put 1 in for x. Then we're going to rewrite and put 2 in for x. All right, so anything to the 0 power is 1. Anything to the first power is itself. And here is our friend squaring a binomial. Square the first, square the last, double this product to complete my task. Okay, well, 3 squared is 9 plus 4a squared. Double this product. Well, this product is negative 6a, doubled to become negative 12a. All right, so let's count these things up. 1 plus 3 is 4, plus 9 is 13. Okay, so you're gone and you're gone. Minus 2a minus 12a is minus 14a, D. All right, this one had a typo in it too. Sorry, lots of typos. Tried to make not any typos on your Friday homework. So which one of these doesn't work? Most of you probably came up with C, because if you put A in, A works, right? 3 minus 1 is 2 over 3. Right? And what's the next thing I'm going to put in? I'm going to put in 4. 4 minus 1 is 3 over 4. And then if we went all the way to 7, right, we're seeing 7 works. 7 minus 1 is 6 over 7. So this one works. B also worked, because if I put in a 5, 5 plus 1, if I put in a 1, 1 plus 1 is 2, 1 plus 2 is 3. If I put in a 2, 2 plus 1 is 3, 2 plus 2 is 4. And if I went all the way to the end, 5 plus 1 is 6, 5 plus 2 is 7. You will see this one does not work. If I put 1 in, I get 1 over 1 plus 1 is 2. I think I typed D wrong on your answer key. Okay, which expression is equivalent to this? Well, if I do believe the answer was D. If I put 1 in, 1 to the 1 over 1, then I'm going to put a 2 in, 2 to the 1/2. Then I'm going to put a 3 in, 3 to the 1/3. Well, 1 to the first is 1. 1/2 power is fancy for square root, and 1/3 power is fancy for cube root. For number 7, we're using our imaginary clock again. So it tells me to start by putting 1 in for n. 20 times? Oh my God, it's going to take forever. No, it's not. So we've got I to the 4 times 1 plus I to the 4 times 2 plus I to the 4 times 3 plus I to the 4 times 4. Does anybody see the pattern? Plus I to the 4 times 5. Well, these are all multiples of 4. I to the 4th plus I to the 8th plus I to the 12th plus I to the 16th plus I to the 20th. Well, if you remember your clock, anything to the 0 power is 1. Anything to the first power is itself. I squared is -1, and I cubed is -I. But look, I to the 4th. 1, 2, 3, 4. That's 1. 5, 6, 7, 8. That's 1. All of these are going to be 1. And I'm going to have 20 of those. So there's my answer. 20. Okay, simplify this one. I'm going to start by putting 1 in for A. X minus 1 squared. X minus 2 squared. X minus 3 squared. X minus 4 squared. That's X minus 1, X minus 4, X minus 9, x minus 16. Add them all up. I have 4x's. That's negative 10. That's negative 20. That's negative 30.